Okay, if I get a phone call in the middle of this, I gotta answer it. So we'll try to get this done. What is the vertex of this problem right here? So this is already pretty much in focal width form. So the vertex of this would be positive 3 for x and negative 1 for y. It's the opposite of these two values. For number 2, what is the focus for this one? So to find the focus, we need to get whatever squared by itself. So to do that, get rid of a half, we multiply both sides by 2. So the 1/2 and the 2 will cancel. So we get 2 times x plus 2 is equal to y plus 1 squared. And I like to use a graph to help me with these problems. My vertex is at negative 2, negative 1. So negative 2, negative 1. And this in front of me is my focal width, which means it is equal to 4c. Divide both sides by 4, and I get c is equal to 1/2. Now, to figure out where our focus is, we have to determine which kind of parabola it is. This says y plus 1 squared. The exponent is on the quantity with y. So that means it's a sideways parabola. So my focus is going to be 1/2 to the right of my vertex, which means my focus is going to be at negative 1.5, negative 1. Okay. You can do this without graphing. It's just you have to know which one gets affected, the x or the y, whenever you solve for c. Graphing just helps put it in perspective. Number 2, what is the directrix for this? So same thing. Let's start off with a graph. And my vertex is at positive 3, positive 2. So 1, 2, 3, 1, 2. And x is squared, so it's an up and down parabola. The squared term is by itself. So that means this term that's in front, negative 8, is equal to 4c. Divide both sides by 4. I get c equals negative 2. So that means my focus is 2 below, and my directrix is 2 above, but the directrix is a line. So therefore, my directrix for number 1 is y equals positive 1, 2, 3, 4. For 2, what is the center of this? So let's put this into perspective real quick. We have x squared minus 8x plus blank, because we're going to have to complete the square, plus y squared plus 4y plus blank is equal to negative 8. I got the negative 8 by subtracting 8 to both sides. So we want to fill in these blanks. To fill in these blanks, we do this step called complete the square, which is where you take your b value, you cut it in half, and then you square it. So this b value is negative 8. Negative 8 divided by 2 is negative 4. And negative 4 squared is a positive 16, so we add 16 to both sides. And 4 divided by 2 is 2, and 2 squared is 4, so we add 4 to both sides. So we get x squared minus 8x plus 16 plus y squared plus 4y plus 4 equals positive 12. Okay. So to put it into descriptive form, we're going to factor these two trinomials. And they factor really quickly because when we complete the square, that's the number they factor into. So this is x minus 4 squared plus y plus 2 squared is equal to 12. Therefore, the center of my circle is at positive 4, negative 2. For 5, like I said, it really helps to graph it. So we're going to graph this one first. To graph it, it's going to be at negative 1, positive 3. See how this 3 is not attached to the y, it's on the opposite side? That's why we don't take the opposite of the sign. So we go left 1, up 1, 2, 3, put a dot. And we can tell that this is a up and down parabola because it's an x squared. It's negative, which means it's going to be going downward, so it's going to look something like that, which means it crosses the x-axis 2 times. What is the vertex for this problem? So to find the vertex, let's move the y's over to the other side. So we get 4x squared minus 16x equals positive y minus 6. And let's factor out a 4 in front. So we're left with x squared minus 4x plus blank is equal to y minus 6. So what we're going to do is we're going to have to complete the square. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So we add 4 to both sides. But here's the thing. On the left side we added 4, but we also factored a 4 out in the very beginning. So that means I'm not really adding 4 to both sides. I'm adding 4 times 4 to both sides, which is 16. So I need to add 16 to the right as well. Okay. So just to explain, I'm not adding 4 to both sides. I'm really adding 16 because of this 4 in front. 4 times 4, 16. So this will factor into 4 parentheses x minus 2 squared equals, and then y minus 6 plus 16, that would be y plus 10. And to get this to look like focal width form, I would multiply both sides by 1/4. So I get x minus 2 squared is equal to 1/4 y plus 10. And my vertex, therefore, is at positive 2, negative 10. If you wanted to, you also could have put this in vertex form, which if we go back to the original step here, I could subtract 10 from both sides. So I get y equals 4 quantity x minus 2 squared minus 10. And from there you can tell that the vertex is positive 2, negative 10. So you could either choose to do this step or this step. It doesn't really matter. They both tell you the vertex. It's just that one of them is going to be the opposite if you're in focal width form. If you're in vertex form, it's going to be the same because it's on the opposite side of the equal sign for the y. The radius for this problem, right away you might think the radius is 3, but your problem's not all solved yet. So to do that, we got to complete the square. So we got x squared plus 8x plus blank plus y squared is equal to 9 plus blank. We're going to cut b in half and then square it to get 16. So we add 16 to both sides. So our problem is now x plus 4 squared plus y squared is equal to 25. And 25 is in the r squared spot. So when you square root both sides, you get the radius is equal to 5. For number 2, find the write the equation in focal width form or vertex form. So let's start off by getting rid of the fraction. If we multiply everything by 3, we'll get rid of the fraction. So multiplying everything by 3 to get rid of the fraction, this will be 3 times that, 3 times that, 3 times that, 3 times that. 3 times y is 3y. 3 times 1/3, those will cancel, and I just get x squared. 3 times negative 4 is negative 12x. 3 times 2 is positive 6. And let's subtract 6 from both sides. So 3y minus 6 is equal to x squared minus 12x. Complete the square. Cut 12 in half. We get negative 6. Square it, we get 36. So we add 36 to both sides. So this is 3y plus 30 equals x squared minus 12x plus 36. And when you factor both sides, 3 comes out of each of them. 3 times y plus 10 equals x minus 6 squared. For number 3, write the center, or write the circle with this equation. So it's going to be an x minus 2 squared plus y plus 3 squared is equal to, and the radius needs to be squared here. So 3 squared is 9. Root 2 squared is just 2. 9 times 2 is 18. Write in focal width or vertex form. So to do that, let's subtract 33 from both sides. So we get x minus 33 equals 4y squared plus 40. And we're going to factor out the 4. Don't take out a y. Y squared plus 10y plus blank. So from here, we got to complete the square. We're going to use the 10 to complete the square here. So 10 divided by 2 is 5, and 5 squared is 25. So we're going to add 25 to the right, but we're not really adding 25. We're adding 4 times 25, which is 100. So this is x plus 67 is equal to 4 times y plus 5 squared. Again, we get the plus 5 from that part in the beginning. And if I want to put this in vertex form, I would just subtract 67 from both sides. So my final answer would be x equals 4 parentheses y plus 5 squared minus 67. If instead I wanted to put it in focal width form, I need to get the squared term by itself. So I would multiply both sides by 1/4, and I would get 1/4 x plus 67 equals y plus 5 squared. So this one up here is in vertex form, and this one down here is in focal width form. Either one of them work. Focal width form is the one that you usually want to use when you graph. You could use this form to graph too. It's just it uses that 1, 3, 5 pattern that many of you guys aren't too fond of. Number 2, what is the name of the shape made up of all points equidistant from a given point? That is a circle. And the set of all points equidistant from a given line and a given point, that would be the parabola. Okay, 6. Use the distance formula for each of these guys. So we're doing 2 of these problems. So for number 1, P is x comma y, F is the point 0, -3, and D is the point 0, 3. So we're going to use the distance formula for each of them. So it's going to be the square root of x minus 0 squared plus y minus a negative makes it a +3 squared. equals, now we need the distance formula from P to D. So this is the square root of, sorry, there should be an X and the X spot for the directrix, because they give you the Y value is 3, but they don't give you an X value, so it should just be X. So it's X minus X squared plus Y minus 3 squared. Okay. So X minus 0 is just X, so that's going to be an X squared. We can square both sides to get rid of the roots, by the way. And then Y plus 3 squared foils out into Y squared plus 6Y plus 9. The shortcut for that is Y squared, 3 squared, and in the middle is 2 times 3 times Y, 6Y. X minus X squared cancels, and Y minus 3 squared, so we get Y squared minus 6Y plus 9. Again, Y squared, negative 3 squared, 2 times negative 3 times Y. So the Y squareds will cancel. Oops. This one should still be there. 9's cancel. And I want to get X squared by itself, so subtract 6Y on both sides. I get X squared equals negative 12Y. For number 2, same steps. X comma Y for our point. Our focus is 4, negative 1, and D is at 2 comma Y. Again, they give us the X value for the directrix. They do not give us Y, so that's why you put it here. And we do distance formula again. So it's the square root of X minus 2 squared plus Y minus a negative 1 is a positive 1 squared equals the square root of X minus 2 squared plus Y minus Y squared. So again, cancel the square roots on both sides. The Y's are going to cancel, so that means we're going to leave this Y by itself. We're not going to mess with it. So on the left side, we got X squared minus 4X plus 4, X squared, negative 2 squared is 4, 2 times negative 2 times X is negative 4X, plus Y plus 1 squared is equal to X squared minus 4X plus 4, just FOIL that out. The 4's cancel on both sides, the X squareds cancel on both sides, and we want to get the Y plus 1 squared by itself, so we add 4X to both sides, and those actually cancel, so we just get Y plus 1 squared is equal to 0. Alright. That's a little awkward. So I'm probably just made up a problem that didn't work. Happens. Okay, 7. Graph this parabola. So start off with your vertex. There is no shift on the Y, no shift on the X, so our vertex is at 0, 0. That number is equal to 4C. So when you solve for C, you get negative 1 is C. And you have to determine whether or not this parabola goes up and down or left and right. So because this is a y squared parabola, it's a left and right. And since C is negative 1, that means you're going to go 1 to the left, and that is your focus at negative 1, 0. You're going to go 1 to the right, and that is your directrix. So that's x equals positive 1. If the line is vertical, it's an x equals graph. If it's horizontal, it'll be y equals. And for the focal endpoints, that number right there that we pointed to, that's called our focal width. So from focus endpoint to focus endpoint, we're going to have a distance of 4, which means we're going to go 2 above, put a point, 2 below, put a point, and there's your parabola. So your focal endpoints are at -1, -2, -1, +2. And the order does not matter. Okay. For this one, to put it in focal width form, we need to get the squared term by itself. So we're going to multiply both sides by 8. So we get 8 times x minus 3 squared is equal to, those cancel, y minus 2 squared. Our vertex is going to be at +3, +2. Our focus, well, let's graph it. So +1, 2, 3, +1, 2. There's our vertex. And we have to use the number that's in front of the variable. That shouldn't be squared. That number is equal to 4c. So divide both sides by 4, and c is equal to 2. And again, it's going to be a sideways parabola, so that means I need to go right 2, put a dot, that's my focus. Left 2, put my line, and that is my directrix. So directrix is x equals 1. Our focus is at 5, 2. So again, our focal width is 8. And since there's 2 halves to a parabola, a top half and a bottom half, half of 8 is 4. So I go up 1, 2, 3, 4, put a dot. Down 1, 2, 3, 4, put a dot. And that will give me my focal width. So my focal endpoints are at 5, 2, 4, 6. And 5, -2. Okay, for this problem, let's get the square term by itself. Put it in focal width form. First off, subtract 2 from both sides. Y minus 2 is equal to 1/12 -1/12 x squared. To get rid of the -1/12, I multiply both sides by -12. So I get -12 times y minus 2 is equal to x squared. So my vertex, there's no shift on x, so x is 0. -2 means that's a shift up 2 for the vertex. So up 2, there's our vertex. It's going to be an up and down parabola because it's x squared. And let's find our other points by setting this equal to 4c. 4c equals -12. Divide both sides by 4, c equals -3. So that means our focus is going to be down 3, 1, 2, 3. That's F. And our directrix is going to be up 1, 2, 3. Remember, your directrix is a line. So focus is at 0, -1. Directrix is at 1, 2, 3, 4. Y equals 5. Our focal endpoints. So we have a focal width of 12. Half of 12 is 6. So we're going to go 6 to the left. 3, 4, 5, 6. 6 to the right. 1, 2, 3, 4, 5, 6. That's our focal width. So our focal endpoints are at -6, -1, +6, -1. Okay. To sketch the graph, let's start off by making the graph. So we got negative 2, positive 3. Negative 2, positive 3. That's our center. Our radius. 18 is not our radius. The square root of 18, which is approximately 4.2, is our radius. So you would write the square root of 18, which breaks down into 3 root 2, or 4.2. So that means we would go 4.2 in every direction. Now, because you're graphing, it's not going to be perfect, and that's okay. So we're going to go up 1, 2, 3, 4, a little bit more than 4. Down 1, 2, 3, 4, a little bit more than 4, because it's 4.2. Right 1, 2, 3, 4.2-ish. Left 1, 2, 3, 4.2-ish. And you connect them all to make your circle. Beautiful circle. So how many times does it cross the y-axis? It crosses once, twice. And is the point inside, outside, or on the circle? So here's how I try. That's my x, that's my y. So I put negative 3 plus 2 squared. Just plug in the values to x and y. Plus 2 minus 3 squared equals 18. That's negative 1 squared plus negative 1 squared equals 18. Or 1 plus 1 is less than 18. Therefore, that means it is inside the circle. You could also plot it. Negative 1, 2, 3, 1, 2 is right there, and therefore it's inside the circle, but this is how you would justify your answer mathematically. And that's it. Good luck, guys.